Welcome to qnawire.
Here we have the two following reactions with their corresponding equilibrium constants, and we want to use this data to calculate the equilibrium constant for the last reaction over here. So notice that the last reaction is going to be equal to minus 1/2 of reaction 2 plus 1/2 of reaction 1. What do I mean by this? What I mean is that we're going to take the value for 1/2 of the initial reaction, that would be CO gas, plus 1/2 of O2 gas is going to produce and be in equilibrium with CO2 as a gas. And the second reaction, if we invert it, we're going to get H2O as a gas is going to produce and be in equilibrium with 1/2 of H2 as a gas. Sorry, equal to H2 as a gas directly, plus 1/2 of oxygen gas. So the corresponding equilibrium constants for each of these, since we're taking 1/2 of the initial value, the new Kc would be equal to the original one to the 1/2. Let's call it Kc1 and Kc2. And for the second case, we're not only going to take the square root, we're going to actually invert it because we changed the direction of the reaction, as you can see over here. Okay, so with this information, we can calculate the overall reaction just by taking the product of both of these reactions over here. Notice that what is going to happen is that upon adding them up together, we're going to get CO2 gas plus 1/2 of oxygen gas plus water is going to produce and be in equilibrium with CO2 gas plus H2 gas plus 1/2 of O2 gas. So over here, the oxygens are going to cancel out, and we're going to end up with the original reaction that we wanted to calculate the equilibrium constant. So the equilibrium constant for this reaction would be equal to Kc1 over Kc2 for the second reaction, and taking the square root for both of them. With the values provided, for Kc1, what we have is 3.3 x to the 91 over 9.1 exponential to the 80. These two values over here. And taking the square root of this gives us 1.9 times 10 to the 5. And with that, it would be all. Thank you very much and have a good one.